Hi, this lecture is all about true and false values, also known as Boolean values. In this lecture, we'll explore the Python's type bool and the operators that we can apply to Boolean values. Earlier, we used Python's arithmetic operators, like multiplication and subtraction, and now we're going to use some of Python's comparison operators. For example, let's compare values 3 and 4 using the less than operator. When this expression is evaluated, we're going to get a true value or false value back. The type of value that we get is type bool. Let's compare 3 with 8, asking if 3 is greater than 8, and it's not, so the value that this expression evaluates to is false. When we evaluate 8 greater than 3, we get true. And if we were to evaluate 3.5 greater than or equal to 3.4, it's also true. Let's compare two ints, 7 with 7. Notice that the operation that we're performing now is the equality operation. And we need to use two equal signs, not one, to signify equality. That's because the single equal sign is already used for the assignment operation. 7 is equal to 7. How about 7 and 7.0? A type int operand with a type float operand. This is also true. Let's assign a couple of variable values. X gets 7, y gets 8, and now we can apply the same equality operator to two variable operands. First, we look up the value that x refers to, which is 7, and y refers to 8, and then 7 is compared with 8. Another operator is the inequality operator. We can check whether 3 is not equal to 4, and that's true. The comparison operators take two values and return a Boolean value, either true or false. Python also has three logical operators, which are operators that are applied to Boolean values and yield Boolean results. The first logical operator that we'll use is the not operator. And we'll begin by creating a variable grade and assigning it the value 80. So grade refers to 80. Now let's write an expression that checks to see whether the grade is a passing grade. Is grade greater than or equal to 50? And that's true. In Canada, 50 is a pass. We'll apply the not operator to that expression now. So we're going to check to see whether grade is not greater than or equal to 50. The order that this expression is evaluated works from inside out. So the grade greater than or equal to 50 part of the expression is evaluated first, and that gives the value true. And then the not operator is applied to true. Something that is not true is false, and that's the result that we get back. We can apply this not operator 2 times in a row, saying that this is asking whether this is not true, which is equivalent to just saying is grade greater than or equal to 50. So rather than including 2 nots in a row, we'll eliminate double negation and instead write the simpler version of that, which would be to just say is grade greater than or equal to 50. Next, let's use the AND operator. First, we'll make another variable named grade2 that refers to the value 70. And now we'll write an expression involving both variables grade and grade2. This expression will check to see whether both of these are passing grade. So is grade greater than or equal to 50, and is grade 2 also greater than or equal to 50. And evaluates to true if both operands are true. So first, this expression is evaluated, and it is true. So then this expression is evaluated, and it is also true, making this entire result a true result. Let's change the value of the variable grade for a moment and set it to 40. We'll rerun this Boolean expression involving the and check to see what we get. Because this first operand is false, the Boolean expression is false. And we don't even go on to check the second operand's value. Now, let's set grade back to 80, and this time change grade 2 to be a failing grade. When this expression is evaluated, first, this part of the expression is evaluated, and that's true. So we move on to evaluating this part of the expression, which is false, and so the expression evaluates to false. To summarize, and again, only evaluates to true if both of its operands are true. Otherwise, it evaluates to false. Finally, let's use the logical operator OR, which also applies to two operands. We'll start by assigning to grade and grade 2 two passing grades. And now we'll write the same expression as before, replacing the AND with an OR. This expression will evaluate to true if at least one of the operands is true. So in this case, we get true. Now, let's assign to grade a failing grade and reevaluate the expression. Python will first evaluate the first part of this expression and determine that it is false. So it will go on to evaluate the second part of the expression, which is true, and because at least one operand is true, the expression evaluates to true. If we set grade to a passing grade and grade 2 to a failing grade, then when the expression is evaluated, it works as follows. Because grade is a passing grade, the expression is evaluated to true at this point without even having to go on to look at the second operand. So to summarize, the Boolean operator OR evaluates to true if at least one of its operands is true, and it evaluates to false otherwise. Now let's combine the operators into single expressions. I've assigned grade and grade 2 passing grades of 80 and 90, and I'd like to evaluate this expression. We're going to apply not to grade greater than or equal to 50, or grade 2 greater than or equal to 50. And there are a couple of different ways that we can interpret this expression depending on order of precedence. The first would be to have the OR operator apply first, and I'll use parentheses to signal that, followed by the not operator. The second would be to actually have the not operator apply first to the first part of the expression, and then the OR operator apply second. So not first, followed by OR first, followed by not. Let's evaluate the expression and see what happens. The value that the expression evaluates to is true. Let's use the parentheses to see which of the two operators applied first. We'll begin by putting the parentheses around the OR part of the expression, ensuring that OR applies before not. And when we do that, the result is false. So that's not what happened when we left out the parentheses, and that means that that's not the order of precedence. Instead, the order of precedence is that not is applied first, as I can show here, followed by OR. The order of precedence for logical operators is not, and then OR. And when we're working with multiple logical operators within an expression, we can use parentheses to ensure that the operations apply in the order we'd like, without having to worry about what the order of precedence is. Sometimes we'll use parentheses to make an expression more readable. For example, in this expression, the arithmetic operators have higher precedence than the Boolean operators or logical operators, so these parentheses are unnecessary, but we include them for readability. Instead, we could have left off the parentheses and had the following. which some may find a little harder to read and understand.